Hello and welcome. In this video, I'm going to show you how to count from 0 to 9 using the Edsim 7-segment display. Before we get any further, let me do a quick recap on the schematic of the Edsim51 7-segment display. Here's the or partial schematic of the 7-segment display of the Edsim51. This is the AD51 and it's connected to 4 7-segment display, display 0, display 1, display 2 and display 3, and to select any of these display, you need to use the decoder here, and in order to use the decoder you need to first of all enable the decoder. So at P0.7 you need to have a logic 1 to select CS here, means chip select the decoder, and to select any of these outputs Q0, Q1, Q2, Q3, which in turn is used to select the display 7-segment display. So I have this put up the combination of A0, A1. Basically there's only 4 combinations. I'm only interested in this display here, the most significant display, which is the display number 3. To select display number 3, we need to put a 1 at A0 and a 1 in A1, and that will select this display. And so I'll be using this particular display here to do the counting. Okay, so let's take a look at the code that we're going to use to count with the 7-segment display. Alright, so this is the beginning of the code. Here set B P0.7 port 0 bit 7, that if you remember earlier I said is used to select the decoder, so we need to set that to a 1, a logic 1. The next 2 bits, which is port 3 bit 0 and port 3 bit 4, or P3.3, P3.4 respectively, we set them to 1. That will select the most significant display, which is display 0. Now R3 here basically is a counter which is related to, associated with this code here. So this counter R3 will repeat, will be used to monitor this portion of the code, and I'll be repeating this portion of the code 10 times in decimal, because 0A in hexa 0A hexa is actually 10 in decimal. So I'll be repeating this portion of the code 10 times. And here's the familiar time delay routine in software. And now this portion here, this is the LUT, stand for Lookup Table. LUT, Lookup Table. So basically it's a table of codes. For those of you who follow my video series, this is actually, if you recognize them, is actually the code that we have determined from the previous video, which is video 24. And if you have not watched that video before this, I do strongly recommend you watch that first before you watch this particular video. So let's look at into a little bit of detail regarding this code here. And so I repeated that couple of lines of code here, and basically I'm saying the lookup table LUT starts at 0200 hexa. So I determine the starting point of this array of values here. These values are listed here. If you notice, this is C0, F9, A4, B0, 99, 92, 82, F8, 80, and 90. And basically these hex code, for example, C0 will give you a digit 0, A4 will give you a 2, and 92 will give you a 5, and so on. So this table actually highlight how you could determine the digit that you want to represent on the display using this hex code here. And the translation into binary is given here. So C0, for example, the 0 would be 0, 0, 0, C would be 1, 1, 0, 0. All right, so that's where these codes come from. Okay, so let's take a look at this portion of the code which I've extracted from the main source code, because there are a couple of concepts that I need to clarify here. So let's take a look. So the first thing is this DPTR. That stands for Data Pointer Register. And basically the function of this register points to a memory location or an address indicated by the contents of this register. So what does it contain? We'll come to that in a minute. Before we go any further, let me define this LUT. LUT is basically a label. The reason why I chose to use LUT, because LUT here stands for Lookup Table. So I define a single array, a single dimensional array of data, which is this one here, and I translate it into a table for you. So the start address of this LUT or lookup table is actually 0200 H hexa, which are repeated here. And so this would be the address of C0H would be 0200H, which is here. And the next address, the next data, the address would be 0201. All right, so this one here would be this, and that's F9, and that would be 0202 A4, and this would be 0203 B0, and so on. So this last one here would be 0208, which is 90 hexa. And basically these are the code that we need to display on the 7-segment display. I think it will become clear to you how this code works in a minute. Sorry. So let's go back to this code here. So it says move DPTR, or rather copy the value of LUT, which is the starting address of this one, which is this one here, and is 0200H. So that value will be copied into this register, and then we clear register A, and here we have move MOVC, which is move code. The address from this particular expression here, which is remember we clear A, so that would be 0. DPTR, remember, has the address of 020 at the starting point here. So if we add these two values up, 0200 add 0, the result will be still 0200, which is the address of this C0, which is this one here, C0. All right, so then that will copy from here, from this point, it will copy that into A, and then this instruction will copy the contents of A to P1. That will display C0 onto the 7 segment, and here we will hold the data by calling the delay, and then we increment dptr by 1, which means it will point to the next data, next value, which is stored in 02001. So that will increment the pointer by 1, and then you will check the counter. If it's not 0, go back here and do it again, and then this will repeat, go back to the beginning of the program. So let's take a look in a little bit more detail, this portion of the code. So what I've done here is I repeated most of the instruction except for this one, which is pretty straightforward, so I'll leave it out. So this one is here, this one is here, this one is here, and finally this one is here. So let's see how this thing works. Remember I say it will copy the value of LUT, which happens to be this, that's the starting point. So that will go into dptr, the pointer. So that will point to that address. It will then copy here, it will copy the resultant address, which is 020 at 0. Remember, it's clear here, A0. So that will point to this. Copy that. All right, copy that C0H to here, and you get A with the C0 hexa, and then from there you copy the contents of A, which is C0, to port 1. That happens to be our display, and that will give you a 0 on the display, and then it would then increment the pointer by 1, because initially this is a 0. So if you increment dptr, so the result would be 0201. So let us go through the cycle one more time, bearing in mind now the address, the data pointer now is pointing to 0201, which is this one here. So 0201 pointed there. This instruction will copy the contents of that address, which happens to be this, into A. All right, and then from A we copied it to P1, which happens to be a 1 for the 7 segment, and then we increment the pointer by 1, so it points to the next data, and so on. So that's how it works. Let's take a look at the video. Okay, so we are in the Edsim51 simulator. Let me just load the code, source code up for the counting of the 7 segment display. So it's loaded. So let me just assemble it. Okay, yeah, let me assemble it. So the code now is assembled and ready to run. But let me just show you the lookup table, the code. If you remember, if you see from the source code here, it says it starts at 0200H, and the first data is C0, F9, A4, And in the code memory, this is where you see it. Address 0200, so that's C0. Then the next data, the code is F9, and that will be address 0201 here, and 0202, A4, and so on. So the actual lookup table is here at those addresses as it should be. Let's take a look at the code, the source code itself. Remember, I started at 000, the two leading zeros are ignored it. But if you like, here we are. So we have all the hexa code for this program here in the code memory. All right, so now it's assembled. Now I'm going to run this through a couple of times using the single step. So now it's assembled, so I'll step it through. So the first line of code is here. That will select the decoder. Yep. So next one, the next two instruction basically will select the display that we need. In this case, that was the most significant display, which is display number 3, which is this one here. All right. So step it through. So R3 is my counter. Remember, I will repeat this portion of the code 10 times, so I'll load it with 0A hexa. So step it through, load the pointer register with the address LUT, which is basically 0200H. So go ahead, execute that. Yep, so that, and the data pointer, where is it? Yeah, it's made up of two 8 bits here. This is the high bit, 02, and the low bit is 00. Remember, it's 0200, so 02 here, 00. So that is your data pointer register. It's made up of two 8 bits. Okay, so now we've done the we clear register A, which is this one here. It's already clear, so step it through. Now here we need to work out the actual address. So it's the contents of DPTR, which is 0200 add the contents of register A, which happens to be 0. So the resultant would be still 0200, which is the first data here, which is C0. So that would be copied into A. So watch A here. Yep. So it's gone in, copied into A. So A now has C0. And then from A, with this instruction from A, you copy that to P1. That happens to be this particular display here. So watch out for this one. And we have it. A 0 is being displayed because that's because we say put in C0. I should have. So that would display that. And so the next round, it will display the 1. Let me just stop it here for a while. Okay, so we display that is a 0. Now, what I've done here is I really commented out the delay because it would be too long if we single step through it. So I commented out so that I skip this portion, move on to the next one. So now I will increment the pointer by 1. So watch this part here, this portion here that we should see rather. That will go up by 1. So step it through. Yep, indeed it has. So it's 0201. So it's pointing to the next data. Check the counter, decrement by 1. Is it 0 yet? No. Go back, clear the register A. Yep, it clears register A. Remember, it contains C0 before. Clear it out. Work out the sum for this one. So now is DPTR. DPTR is actually 0201 plus a 0. That is 0201. Copy the contents of that address, which happen to be F9, into A register. Watch A register here. Yep, we've got F9, and then we copy the contents of A, which happens to be F9, copy it to P1, which is this one here. Watch it turn into a 1. Yep, it does. And increment the pointer by 1, so now it's pointing at 0202, which is this next code here. Now I'm going to stop the single step here, and we're going to do a straight run. Okay, so I've got rid of the comment here, so now I have the delay back in. So I've already assembled the code. So let's just do a run and watch this 7-segment count. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and back to 0 again. So I'll pause the demonstration here. Okay, that's it for this video. The source code that I've used for this particular video is given in the link below. And so thanks for watching, and hope to see you in the next video. Okay, bye.